Hi, it is my pleasure to introduce to you Chavi Prom, an application that we have developed at Tata Medical Center over the past few years. To introduce the topic, we first need to know what exactly is a patient reported outcome. So, the clear definition of a patient reported outcome is something that is reported by the patient, and anything like symptom, functional status, psychological, social issues, as well as their experience with healthcare delivery can be considered as a patient reported outcome. The measure, that is the patient reported outcome measure or a PROM, is basically a scientifically validated measurement system which allows you to quantify these reported outcomes, allowing you to make comparisons which can have clinical impact. Now, why do we need patient reported outcome measures? Because at a fundamental level, patient reported outcome measures represent a method of giving the control back to the patients. It is a bottom up reporting system where the patient takes the role of provider of information rather than being the responder of information. Because the patient themselves report these outcomes, inter-rater variability is eliminated and intra-rater variability is minimized. This is an excellent tool for subjective symptoms, and this has been shown in multiple trials across diverse sites and not only cancer, that patient reported outcome measures are better at catching low grade, more distressing symptoms as compared to clinician reported outcomes. Most importantly, because these questionnaires undergo a rigorous standardization method, outcome reporting can be standardized unlike clinical outcome reporting. Now, routine measurement of quality of life or patient reported outcomes improves outcome, and this is not data based upon a single study. There is now a Cochrane review which was actually published 4 years ago, which at that time evaluated outcomes from 116 randomized controlled trials and came with the conclusion that evaluation of patient reported outcomes improves patient and provider communication, allows for better quality of life and possibly better disease control in some settings, and allows for better diagnosis of the disease. Most importantly, we believe that in busy healthcare settings, it allows the assessment and interview to be focused on critical issues which matter to the patient most. Now, what is the key requirement for such a routine measurement? You need to have a patient who can provide an assessment on an electronic system. Now, why not paper? Because paper data needs to be quantified before it can be interpreted in the context of the data that is provided by other patients. And these needs to be provided in a fashion that it can be easily reviewed by the physician. Please remember that asking symptoms from the patient is not a patient reported outcome, because here the symptom flow is essentially reversed, and more importantly, the measurement is not standardized. So why did we develop the Chavi Prom? We wanted to develop an application using open source software which is easy to use for both the patient and doctors, extensible for future advances in this field like computerized adaptive testing and integration of artificial intelligence, secure from the ground up, able to adjust for multiple healthcare systems, and adopt to any number of instruments. So, unlike many systems which are available commercially, we do not restrict ourselves to a particular set of instruments. You can use any number of instruments that you want. It must be installable in the local network or available as a cloud service. And of course, one of our motivators was also that the output should be ready to integrate with Chavi, India's premier oncological imaging bank. This is the software stack that we have used. All of these are open source software with a long history of maintenance and security. We have built this software using stable and active open source software projects. External APIs are not available, which limits the attack cross section. Access control is through a username and password, and additional two-factor authentication can be easily integrated. The application provides strict access control which is role based, so patients and providers must belong to the same institution to view their records. Additional further granular evaluation on a departmental level is also possible. Patient portal can be made accessible by the patients, not by the healthcare providers. Separate permission for viewing and adding patient details are there. So there can be roles who are capable of viewing the patient details but not editing them. Questionnaire design and translations also can have a separate set of permissions. So all of these make the application very secure. Now let's take a look at the feature set. So we have several patient facing features which we'll be discussing, but authentication access to ensure security and encrypted data storage are two very critical things that have already been implemented. Now when the patient enters into the system, which looks like this currently, and why currently? Because it is quite likely that as time passes this system will evolve. They can easily see the link to complete the questionnaire. The system can be extended in a manner such that it can automatically redirect patients to the page where they can automatically complete their questionnaire. Each questionnaire is shown with a very clear indicator of the order in which it is to be answered, when the questionnaire was last answered, and a prominent button which allows them to answer the question. There are several best practices which are being followed. For example, each question is demonstrated or shown to the patient one at a time. We allow the users to see this without distraction of other questions, and the text is always made large such that it can be easily seen. There is provision for attaching media. For example, you can add audio or video with the question, and even some of these response types allow you to add media. For example, in these buttons you can add small media which explains what is written in the text. So this is very useful if you have patients who have limited literacy. It automatically allows you to display the translation at the back end. So once the translation is in place, it can automatically display this translation in the patient's preferred language. What is important to understand is that because these instruments are validated strictly, their translations also are strictly validated, and therefore we do not recommend using machine translation for doing or visualizing the translation. Once the patient has answered the question, a configurable system is placed which allows us to restrict the time interval between two responses. This prevents duplicate submissions and also allows the patient to give a clear indicator of when the questionnaire will be available next for the answering. Patient has a portal which they can log in using their login ID and password, which allows them to see what are the different types of questionnaires that were available to them, when did they answer these questionnaires, and what were their trends. This again is something that can be translated and viewable to them with the language of their choice. Now let's come to questionnaire design, because any of these such systems must have a robust questionnaire design system also integrated with it. Now questionnaire design is based again on role-based access control to make sure there is security. There is a logical data hierarchy which we will be discussing a little bit in detail. And most importantly, we allow several advanced features like advanced score computations, computational additional of conditional logic, time intervals, redirects, etc. Before we go further, let us take a step back and understand what exactly are patient reported outcome measures again. So patient reported outcome measures measure a latent rate. What is a latent rate? Is something that cannot be objectively measured like a pulse rate or blood pressure. And because this is a latent rate, we need something to quantify it, and this something which is used to quantify it is called as a construct. For example, a VAS pain score is a construct to measure the latent rate pain. Each of these constructs can have one or more items associated with the construct, and taken together the sum or the average or other ways of manipulation of item scores is there, which allow you to measure the latent rate. Now, whenever a questionnaire is designed, it undergoes a rigorous validation to ensure that the construct is able to measure the latent rate properly. So therefore, the first thing that the system allows you to do is specify the construct scales, and we recommend that you use standardized definitions of the construct scales for every questionnaire that you design. Here, for example, you have the appetite loss, cognitive function and constipation constructs from the URT-CQLQ C30 questionnaire. Notice this equation setting which allows us to calculate the scores of these constructs dynamically without you needing to do this manually at the end. This is the form for creating a new construct scale, and as you can see, we provide you with the information to supply us with the name, the instrument name and instrument version. These are pretty routine. But what is not routine is the advanced settings, which allows you to set up things like the score direction. That is, specify if a higher score is better or a lower score is better. Specify the threshold score if it is available, which allows you to specify if a score beyond a certain threshold can be considered important. Similarly, specify a minimum clinical important difference, which outlines how much difference there should be between two repeated measures to make sure that this difference is actually a clinically important difference. We can specify the population normative score means and normative score deviations, standard deviations, and this data is usually available for the most important validated questionnaires. Because each of the construct scale requires a specific equation to calculate the score, we have provided a very flexible system to calculate these scores. Again, each of the different type of patient reported outcome measures have a different method by which this construct scale value is calculated. For example, the URTC scale and the FACT-G scale have two very different methods. And therefore, a comprehensive equation builder is available for the end user, which allows them to specify the equation in a mathematical term. Most importantly, we do not only allow plus, minus, multiplication and division, but also several mathematical functions like calculation of the mean, median, sum, etc., and implement conditional logic at the back end, which allows you to specify multiple conditions with else if statements. Coming to the items themselves, each item is associated with a type of response. So here, for example, having a trouble sleeping is associated with the response type, which is a Likert scale. And once an item has been created, you can then see a dynamic display of the translations in which this item is available. Clicking of these buttons allow you to translate the items. This is the form interface that comes. So you select the construct scale, then you enter the name of the item, you add additional media if required, and this media can be an audio file, image file or video file, and once selected it will automatically appear below the item, allowing patients to hear, for example, the same question in an audio format. There are again clinical scoring parameters as in case of the construct, and this allow you to specify at an item level whether there is a threshold score that should be met or a normative score for the population, as well as the direction of the score, which indicates an improvement or worsening. Coming to the response types of the items, we have 4 different types of responses: a Likert scale, a range response, a text response and a numeric response. Now these cover the vast majority of patient reported outcome measures that we know of, which are validated and widely used. The Likert scale option, for example, allows you to set up options for your Likert scale, and one of the advantages of separating these is that you do not need to create the same Likert options again and again for the different questionnaires. For example, URTC has nearly an item bank of 600 items, and each of these items have the same response type, that is these 4 response type, and just adding this single response type allows you to attach this Likert scale with all 600 of those URTC items. Again, there is a dynamic translation interface provided, so clicking on these buttons allows you to enter the translation. Not only that, we also allow you to add an emoji. Now this is something that is often not done in the quality of life questionnaire, but we believe that as times have evolved and patients have gotten accustomed to more modern methods of interacting in mobile phones, emojis actually convey a lot of information and meaning for the patient. Most importantly, they can also be understood by patients with limited literacy. There is an option media available which actually allows you to add a media option like an audio, video or an image to this response option. This is the way the translation interface looks like. So items, questionnaires, whenever they are translated, can be translated using this very simplified translation interface. This allows you to enter the text. For example, here in Hindi you can simply enter the text, and most importantly you can attach an Hindi media file which will automatically display if the patient selects the language as Hindi. The range scale actually allows you to specify a range, classic example being a VAS score for pain. Again, please note that we provide you with translation systems for the text, no pain and most severe pain imaginable here. This is an example of how the range scale will look like. Again, translation system is integrated. And once you have set up the items, constructs, you can now start adding them to your questionnaire. And this is how the questionnaire view looks like. So you can add translation to a questionnaire, you can add items to a questionnaire, and when you create the questionnaire you can specify things like at what time interval this questionnaire can be answered again. So for example, if you have a QLQ C30 questionnaire, ideally that should be answered at 7 days interval. So this is something that you can specify here. Questionnaire order basically implies that you have multiple questionnaires for the patient, then this will be allowed them to display it in 1, 2 and 3 order. And questionnaire redirect allows you to redirect to another questionnaire automatically. There is a very simple interface for adding items, so you just simply select it and it will automatically appear on the right side. You can drag and drop this to change or reorder the question numbers. Now please remember that we recommend that you follow the question numbering which is provided with the questionnaire, but it is possible for you to create abbreviated instruments. So for example, here instead of asking all 5 questions associated with physical questioning, you can choose to ask 1 or 2, and you can also change the order of the questions if you wish. We also provide you with a rule manager. So what is a rule manager? It basically allows you to define rules to display the question or the item in the questionnaire. So for example, here if there are questions like the do you need to stay in the bed or chair during the day, you can choose to display it or not based upon the response to a previous question, and this actually allows you to comprehensively decide whether a particular question should be displayed or not. Again, we recommend that you follow the guidelines of the questionnaire that you are using whenever setting up these kind of visibility rules. This is the rule interface, and please remember that we are setting or showing whether this questionnaire is optional for construct score calculation. Now if the question item is actually required for calculation of the construct score, we will not be able to hide it using the rules. Similarly, if you set up a rule for a particular question, say question 4 over here, and you try to move it in front of question 2 or before question 2, the system will automatically show an error message. You can set up rules, multiple rules, and manage them into a rule group and combine one or more rule groups for complex decision making algorithms. Now lastly, coming to the healthcare provider part, we provide again granular role based access controls. Scores and responses can be displayed in a logical order with clear visualization of the longitudinal responses, and most importantly, and this is very unique to our software, we provide aggregated information for the patient data in addition to normative data. So let's understand what this means. So when the healthcare provider first tries to view the patient data, they can actually select and filter this data according to multiple conditions. So for example, over here they can choose to filter it based upon the gender. So when they see the responses, they can actually see the responses of all genders, but they can choose to, for example, see the genders which are male or female or vice versa. This can be combined with the diagnosis filter and the treatment filter together. So you can get a drill down view of the quality of life your patients with respect to the patient data for similar patients in your data set. We show you dynamically how many patients are actually contributing to the aggregation, as well as what is the time interval over which the plot is being displayed and the range of the time interval over which the plot is being displayed. In addition, there is some view about the patient data, the questionnaires they have answered, and the number of times they have answered this questionnaire, as well as the last date on which the response has been received. Each of the sections inside this healthcare provider view is divided so that you get attention to the most important results. The top line results show constructs which are worsening significantly. So here you can see the plots in the black line indicating of the patient response, and these are all dynamic interactive plots. So for example, if you hover over here with the tooltip, it will show you what is the exact score value, the date and the time interval from assessment. So please remember that this time interval that is showing over here in weeks again is customizable. So let's go back to the filter section, and you can see here responses are being shown with respect to date of registration, but you can show responses with respect to other dates like the date of diagnosis of a particular diagnosis, date of start of a particular treatment, and so on. The aggregation will also change based on this. So if you set the date of start as the date of diagnosis, then the aggregation will also take into account the fact that remaining patients will also have the measurements calculated from the date of diagnosis. And this happens dynamically on the dashboard, allowing you to see the response in real time with respect to the other patients. Please remember that for any calculation, we do not calculate the value for the aggregation using the same patient's data or the index patient data. So this is an example of how the chart particularly looks like. You see the score for the day that is being viewed over here. This is a change indicator which shows how much the score has changed, whether it is increasing or decreasing, and there is a color code to indicate whether this change is beneficial or harmful to the patient. Red indicates a harmful change and a green indicates a beneficial change. You can visualize the score trajectory as we have already discussed. This blue line actually represents the normative score of the population, with the bands indicating one standard deviation on either side of the mean. And the dotted lines with the error bars represent the normative aggregated data. This aggregated data display actually allows you to compare the patient's response with the other patient's response and tells you whether this patient is actually a responder which is within the limits or completely out of bounds. Finally, we show what is the meaning of this score. So if the score indicates that the arrow is red is down, it means that for this score to show an improvement, ideally there should be a reduction. Coming to the healthcare provider view, you can see item wise results, and each item that the patient has responded to can be seen. We provide you with an efficient filtering mechanism. So if you are interested in a particular type of symptom, you can filter to that symptom, and this display will automatically adjust and show you those items only. Again, similar indicators for the trend are shown. Change with respect to the previous score is shown, and we show you these plots in particular color codes based upon the severity for Likert responses, which are the most common type of response used for quality of life measures. So the key takeaway: we have developed an open source system which can be considered as a step towards making routine patient reported outcome monitoring available and accessible to all. We have developed an extensive set of features with unique features like review of aggregated responses and statistics. This system is capable for potential integration with advanced AI-based predictive modeling and developed keeping in mind the future of computerized adaptive testing. Thank you.